Yes.
Um, well, I wanted to go through. I was passing through natural language processing before he ended the semester, but Sarah told me to look through language models. Yeah, and I think Hanel was looking through the large language models. I won't reach there, so I'm gonna start from the ones that came before. Mm, yeah, lucky unluckily my my presentation got issues, so I have been trying to create something from the few notes that I had taken down and the resources that I got it from. So from what I got, like a natural language, no, no, a language model is specifically a model. We model how the human's brain ability to produce natural language. That's the simple term. Or we can say it's the probability distribution of a words or a word sequence. Uh, see? Yes, yeah. As you can see, language models can be used to create, like, can be used, can be enforced. It can help us to create a lot of, make a lot of things. For example, in speech recognition, machine translation, language generation, or text generation. Then uh, I found that there are two types of language models. We have the probabilistic models, sorry, and then the neural network based models. I think today I'm gonna speak mostly of the probabilistic models, and these ones are static. We use they are statistical methods. The probabilistic models are statistical methods, and in one of them, the best one that I looked through was the word n-gram language model. This one is specifically like it helps us to. It's based on the assumption that it's based on the assumption that the probability of a next word in a sequence depends on a fixed number of words that come before it. The what n-gram model, as you hear the n-gram, it means that the n takes the number of words. Or n stands for number of words. So you can have, let's say, there are very many types. There is a unigram for the unigram model in the n-gram model. For the unigram, we specifically say that each word is independent in the sequence of any other word. So the occurrence of each word is given a probability which is independent to any other word in the sequence. But this one is usually based on on a specific document, what I recall. Then we have a binary word, binary. We have a bigram, I think, bigram, where n is 2. So for a bigram, we consider one word exactly after the word we are looking at. So if we get a sentence, unluckily, when I was trying to create the PowerPoint, I kind of stopped there, but I'll try to explain from the few notes I have. So in a bigram, uh, so in a bigram, since we are using, like, it's called two because we are looking at the next word, the word we want to, the probability of the word we are looking at, and the word after it. So we are looking at two words, so it's called bigram. Then like anyway, you can just add like a trigram. That means you're basing on two words, and nrigram. That means you're basing on n words. Then I think there was a lot of mathematics There are a lot of mathematics, and like I can't capture it right now. I think next time the next time we come, I'll pass through it. A lot of like methods where how we estimate the probability of the next word in the sequence using that of the previous words. Mm, I saw a few problems. Yeah, there were a few problems, like the out of vocabulary words here, like when you're writing a word that is out of English, and uh, the 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 model was taught using English. So you have a word that is not in the vocabulary that was given to the model before. Then mm, I saw something also called a skip gram language. Here in a skip gram, instead of using like instead of coming from a word exactly after it, we use like we skip a word in between the we skip a word like after one word we skip a word. I can't explain it exactly. Like I think I can't write. I'm sorry. I'm so sorry. I think I'm going to have to after I recover the next the PowerPoint I created. I'll pass through it very well. And there's also this thing that I had got. Mm, mhm. Yeah, this is it was a YouTube, but I took a screenshot. So it describes what the language model is in short terms. Like since it's a probability distribution of strings, now here like if you have a word of we have these the four sentences, so you can see that P1 is has a higher probability to be found in an English sentence. A quick it has a higher probability than P2. Anyway, than all of them to be in an English sentence because it makes uh, uh, an English, it is grammatically right. Then P2 has all English words, but the grammar ain't right. Like if you read it, it doesn't make sense, but it has all English words. So it's less likely to happen in a sentence like P1, but it is more likely to happen in a sentence like P3 because P3 has uh, two un-English words with only two English words in it. And P4 uh, has P4 has entirely no English words in it. And that's what the entire language model I think was about from what I saw, and from what I recorded. But I think maybe next time I'll pass through the entire concept as a whole by anyway if I recover my my PPT. So thank you, and I'm really sorry, but thank you very much for your time.
Easton, there is no need to be sorry. Again, what matters is to start and keep going.